particular tutorial, we're going to focus on the Beers-Lambert law, and I'm going to use it to help you identify how to find the unknown concentration. One of the first things I want you to realize is that you can do this without calculators for the base exam. You really don't need a calculator. It's easy to estimate. And so the absorbance for the unknown that we are given, though, is 0.27. So absorbances do not have a unit, so we don't need to worry about adding a unit behind 0.27. I can see if I have an absorbance, so if all of my standards are plotted already, if I have an absorbance of 0.27, so that will put me in between 0.2 and 0.3, so closer to 0.3 than it is 0.2. So somewhere around here, and my concentration should be in between 10 and 15, okay? That is kind of how you can estimate on the exam, but here's the way to get it if you're trying to get the exact estimate, the exact value. So one thing you want to be aware of is our slope rule. So back in algebra, you might have learned that y2 minus y1 over x2 minus x1 is equal to the slope. I'm going to take a point on this graph that is meeting at an intercept. And so I see this is a great one to get. I wouldn't get this one here because it's the initial. It's my y1 or my x1. So I'm going to take this one. And so the y value that matches up with this is 0.4. Okay, minus 0 again. And then the x value for that 0.4 is 20. So 20 minus 0. And when I put this in the calculator, I will get 0.02. Now, I also want to acknowledge a equation that we should definitely be aware of, and that is the absorbance equals epsilon path length of light times C, which is the concentration. The other thing I want you to be aware of is A, well, the absorbance, over C is actually equal to my slope, okay? And since A over C is equal to my slope, then I can therefore find my concentration value just by already having my slope and inputting my absorbance value up here. So let's just do that. So absorbance, again, that we were given is 0.27 over the concentration, which we're trying to find, equals the slope value that we just got over here, 0.02. And then, so, and because I'm looking for my C, I'm going to do a bit of a rearranging of equations here. So times C, and then I want to get C by itself. So I do divided by 0.2 divided by 0.2. And then I get 0.27 divided by 0.02 equals C. I just rearranged my equation in 2 steps here. And then I got my 0.27, which is my absorbance, over my slope equals C. And so now, once I put this into the calculator, 0.27 over 0.02, I get 13.5. And my units is going to be the same units that you see on this graph once I finish everything, and that is nanograms per microliter. And you'll see that this 13.5 is in fact in between 10 and 15, but closer to 15 than it is 10. That's it.